Hi friends, we are all using electricity in our homes. But do you know where the electricity comes from? How is it supplied to our homes? How are the electrical connections done in our home? What is earthing and the safety devices used in our homes? We'll be discussing all these practical things in this video on domestic electric circuits. I'm sure after watching this video, you'll become an expert in domestic electric circuits. And when the electrician comes to your home, you know what to discuss with him. Let's start with how do we get electricity at our homes. Electricity is being generated at some power station which is usually far away from the city. The power station has an electric generator that produces a massive amount of electricity. The electric power is generated at a very high voltage of about 11 kilovolts. That's 11,000 volts. The generated electricity is transmitted from the power station through long electric cables. Now we know that from Joule's law of heating that when current flows in the wires, heat will be produced. So some energy will be lost in the form of heat. The heat loss is directly proportional to the square of the current. So if you want to minimize the heat loss, the current should be very small. To reduce the current, the voltage is increased using a transformer before the transmission. The voltage is typically stepped up from 11 kilovolts to a much higher voltage of 132 kilovolts using a step-up transformer. The electric power is transmitted to the main substation using long electric cables. At the main substation, the voltage is stepped down from 132 kilovolts to 33 kilovolts using a step-down transformer. At the intermediate substation, the voltage is stepped down from 33 kilovolts to 11 kilovolts. And finally, at the city substation, the voltage is stepped down to a much lower value and is supplied to our homes.
देखो समझना इस चीज को समझाएंगे थोड़ा ठीक है। सबसे पहले जो है ना जनरेट जो जहाँ होता है जहाँ पे हम लोग देखते हैं पावर प्लांट होता है थर्मल पावर प्लांट हाइड्रोइलेक्ट्रिक पावर प्लांट वहाँ पर जो है ना कि टरबाइन को रोटेट कराया जाता है। जैसे हाइड्रोइलेक्ट्रिक पावर प्लांट में बहुत हाई एल्टीट्यूड से वाटर को फॉल कराया जाता है उससे जो टरबाइन रोटेट करता है इलेक्ट्रिसिटी प्रोड्यूस होता है। अब देखो इलेक्ट्रिसिटी ऐसा चीज है ना कहीं इसको स्टोर करके नहीं रख सकते। हमारे यहाँ इस यहाँ पर रूम में आया इलेक्ट्रिसिटी कहीं स्टोर करने कोई जगह है नहीं है स्टोर करके नहीं रख सकते। वहाँ पर जो भी इलेक्ट्रिसिटी जनरेट होता है उस समय हो रहा है देन एंड देयर उसको सप्लाई किया जा रहा है। जैसे वहाँ से ट्रांसफार्मर टरबाइन से जनरेटर से टरबाइन में जाता है टरबाइन से यहाँ पे देख रहे हो ब्रिज सब स्टेशन में दिया था ट्रांसफार्मर। एक ट्रांसफार्मर होता है स्टेप अप ट्रांसफार्मर दो तरह का होता है एक स्टेप अप एक स्टेप डाउन होता है। स्टेप अप का काम है 11 केवी को बढ़ा करके 132 केवी स्टोर करके बना लेता है ये और फिर वहां से ग्रिड ये सब ग्रिड में जो है ना केबल के थ्रू से सप्लाई करता है और फिर नेक्स्ट ट्रांसफार्मर में 33 केवी में गया कम गया ये स्टेप डाउन हो गया फिर उसको और कम किया 11 केवी में गया फिर एक बार और स्टेप डाउन हुआ ट्रांसफार्मर में और उसका फिर एक और ट्रांसफार्मर में गया जो 220 वोल्ट में इसको रिड्यूस कर दिया यानी स्टेप डाउन हुआ 3 स्टेप्स में देखो स्टेप डाउन हुआ। फिर हमारे घर में 220 वोल्ट का सप्लाई होता है। अगर जितना सप्लाई वहां हो रहा है पावर प्लांट में उतना सप्लाई घर में देंगे तो वो इलेक्ट्रिसिटी जो बहुत हाई वोल्टेज का करंट और हाई वोल्टेज और करंट होगा तो वो हमारे घर में जितना इलेक्ट्रिकल अप्लायंसेस होगा उसको क्या कर देगा डैमेज कर देगा। इसीलिए जो है ना इसको कहते हैं पावर ट्रांसमिशन। पावर ट्रांसमिशन जो होता है कि यहाँ वहां से यहाँ तक आते आते हम लोग जो सुटेबल पावर उसको बना करके घर में सप्लाई करते हैं। जैसे हम लोग भोजन का प्रोसेसिंग होता है जैसे चावल को कैसे हम लोग प्रोड्यूस करते हैं फिर कैसे उसको सही ढंग से करके फिर हम लोग के तक आते आते उसको सही करके ही ना हम लोग भोजन पकाते हैं खाते हैं हैं तो उसी तरह इसका प्रोसेसिंग होता है कि इलेक्ट्रिसिटी जो हम लोग को मिलता है ना इलेक्ट्रिसिटी जो हम लोग को मिल रहा है वो काफी कन्वीनियंट फॉर्म में मिल रहा है लेकिन इसका प्रोडक्शन में इसका ट्रांसमिशन में काफी डिफिकल्टी जाता है जो कि हमको वो चीज को पता अनुभव नहीं होता है। इसी सब चीज में जो भी खर्चा लगता है गवर्नमेंट उसी का पैसा हम लोग से लेता है इलेक्ट्रिसिटी बिल के रूप में लेता है। समझे ये बात होता है। बंद कर दो उधर का बंद कर दो तो आगे देखते हैं तो क्या बता रहा है ध्यान से देखना पड़ेगा यहाँ पे ठीक से बंद कर दो। कौन है ठीक से बंद कर दो, डिस्टर्ब होगा क्लास।
In India, the voltage that we get in our homes is 220 volts. In United States, the voltage is 110 volts. Did you know that the voltage or the current that we are getting is alternating in nature? The polarity keeps on changing. That's why it's called alternating current. The electricity comes to our homes through two thick insulated wires. One of these wires is called the live wire or phase wire, and the other wire is called the neutral wire. The live wire in India has the potential of 220 volts, and the neutral wire has the ground potential of 0 volts. So what is the potential difference? It's going to be 220 minus 0, that is 220 volts. The two insulated wires, live and neutral wire, enter a box fitted in the house. In this box, a main fuse is put on the live wire. This fuse acts as a safety device and has a high rating of about 40 ampere or even more. The two wires then enter the electricity meter. The meter is installed by the city's electricity department and it records the
देखना पड़ेगा ध्यान से कि फ्यूज इज ऑलवेज कनेक्टेड जस्ट बिफोर योर इलेक्ट्रिकल मीटर से पहले, ताकि मीटर को भी बचाना है ना। मीटर के बाद लगने तो मीटर तो उड़ जाएगा हमारा। तो मीटर से जस्ट बिफोर फ्यूज को हमेशा कनेक्ट करना है, ये ध्यान रखना है। और फ्यूज इज ऑलवेज कनेक्टेड इन सीरीज, सीरीज में ही कनेक्ट किया जाता है हमेशा फ्यूज, ठीक है। और फ्यूज वायर में जो होता है हम लोग कौन सा वायर देखते हैं जिसका मेल्टिंग पॉइंट लो होता है।
electrical energy consumed in the house. What is the unit used by the electricity meter? That's right, kilowatt hour, because kilowatt hour is the commercial unit of electrical energy. The two wires coming out of the electricity meter are connected to a main switch. The main switch can be used to turn off the electrical supply. For example, when repairing some electrical faults. The main switch is a double pole switch because it gets the connection of the live and neutral wires simultaneously from the main supply. After the main switch, there is the distribution box. From the distribution box, the wires go to the different parts of the house. The distribution box looks something like this, and it has many MCBs. MCB stands for Miniature Circuit Breaker. MCBs are safety devices like fuses, and we'll look at these in detail later in the video.
एपिक ऑनलाइन एक्शन गेम बहुत होकर डाउनलोड करें और फालतू युद्ध के साथ अपना दिन बनाएं। ये सिर्फ एक गेम नहीं है, बल्कि एक एक्सपीरियंस है जहां धातु की चीज, जलते आसमान और हर शॉट की चिंगारी शानदार स्पेशल इफेक्ट के साथ दिखती है। मिलिए आपको टी-टाइम से।
There are only MCBs in the distribution box, since each MCB is for a separate circuit in the house. If I switch off the MCBs, the power supply in the house is cut off, and when I switch it on again, the power is back. I'm sure you've noticed that there are two types of electrical sockets in your house. Small sockets like these and large sockets like these. Do you know why? Because there are two types of circuits in a house. A lighting circuit and a power circuit. The lighting circuit allows a maximum of 5 ampere current and is used for low power rating devices such as bulbs, fans, and is also connected to the small sockets in the house. That's why for the lower power rating appliances like televisions, computers, we use the small sockets in the house. The power circuit allows a maximum of 15 ampere current and is connected to the large sockets in the house. That's why we use the large sockets for high power rating devices such as electric iron, heater, geyser, and refrigerator. Each distribution circuit has a separate fuse or MCB so that if there's a fault in one circuit, the other one will remain unaffected. These distribution circuits are connected in parallel. Some of the distribution circuits are lighting circuits and they have a 5 ampere MCB or slightly higher, a 6 ampere MCB. Some of the distribution circuits are power circuits and they usually have a 15 ampere or a 16 ampere MCB. We discussed about the live and neutral wire. Do you know that there's also a third wire in the house called the earth wire? The earth wire is connected to the earth connection in the house. The earth connection or local earthing is done near the electricity meter of the house. A hole about 2 to 3 meters deep is dug in the ground and a copper rod is inserted in the hole. The end of the copper rod has a thick copper plate and it is buried in the ground. The plate is surrounded by a mixture of charcoal and salt to make a good contact between the plate and the earth. The upper end of the copper rod is joined to the earth connection at the electricity meter. The goal of local earthing is to provide a safety mechanism. For example, if due to some fault such as short circuiting and excessive current flows through the wires, then the excessive current will pass through the earth wire if there is local earthing. But if there is no local earthing done, then the wires in the house may get overheated and it can cause fire. As we discussed, there are 3 wires in the house: live wire, neutral wire, and earth wire. If you look at this plug, you can see that there are 3 wires of different colors coming out of this plug. The plastic insulation of these wires is of different colors. The red wire is the live wire, the black wire is the neutral wire, and the green wire is the earth wire. This is the old convention. The new convention is brown color is used for the live wire, light blue for the neutral wire, and green or yellow for the earth wire. This color coding helps to distinguish between the different wires. Let's place the old and new color coding for the live, neutral, and earth wire on our concept board. All the three wires, live wire, neutral wire, and earth wire, are going around the house and to each room. Let's say there's a light bulb in the room. How is the light bulb connected to the wires? One end of the bulb holder is connected to the live wire, and the other end is connected to the neutral wire. Here the earth wire is not used. The switch is always connected to the live wire. Now if another bulb is there in the room, it will be connected in a similar way. Are the two bulbs in series or parallel? That's right, the bulbs are in parallel. The advantage of parallel connection is that both the bulbs get the full voltage, 220 volts in this case, and they can go brightly at the full voltage. Also, if one of the bulbs gets fused, then the other bulb will continue to work. But if you connect the bulbs in series, then the voltage will get divided between the bulbs, and they will not get the full voltage. And if one of the bulbs gets fused, then the other bulb will also stop working. That's why everything in the house, from lights, fans, televisions to the refrigerator, they are all connected in parallel. Next, let's look at how the three pin sockets in the house are connected. The three pin sockets have three holes. The upper and middle hole in the socket is for the earth connection. The hole on the right side is for the connection to the live wire, and the hole on the left side is for the connection to the neutral wire. In the three pin plug, the top pin is for the earth connection. The pin on the left is for the live connection, and the pin on the right is the neutral pin. As you can see, the earth pin is thicker and longer than the other two pins. Why? The earth pin is made long so that the earth connection is made first. This ensures safety before the live and neutral pins are connected. The earth pin is thicker so that it cannot accidentally be put into the live or neutral hole of the socket. When a three-pin plug is inserted into a three-pin socket, all the three connections are made: live, neutral, and earth connection. We know that the live and neutral wires supply the potential difference to the appliance. In India, the potential difference is 220 volts. Now let's see how the earth wire is used for earthing an appliance. Let's consider an electrical appliance like an electric iron or an electric kettle. Due to wear and tear or excessive heating, the plastic insulation of the wires gets worn or burnt. As a result, the naked live wire may touch the metal body of the appliance. This is dangerous because now the whole metal body of the appliance is at 220 volts. So if you touch the appliance, we get a bad electric shock. To avoid the risk of electric shocks, for safety, the metal body of the appliance is earthed. Earth is done by connecting the metal body of the appliance to the earth wire. So when the three-pin plug of the appliance is put in the three-pin socket, the connection with the earth wire is also made. Now if there is any fault in the appliance, and by chance the live wire touches the metal body of the appliance, but since the appliance is earth, the current will pass directly to the earth, to the earth wire. The current will not pass through our body, and so we won't get an electric shock. The earthing of electrical appliances is used as a safety measure, and it prevents us from getting a shock. Earthing is usually done for electrical appliances that we touch and they draw high current. What are some examples? Electric iron, electric kettle, refrigerator, washing machine, microwave oven. Electric bulbs and tube lights are not earthed since we don't touch them when they are switched on. So next time when you are using an electrical appliance and you feel an electric shock when you touch the body of the appliance, do remember to have the wiring of the appliance checked and also the earthing of the appliance. Once the fault is fixed, you should not feel an electric shock when using the appliance. Let's put earthing on our concept board. Now let's discuss about the situation when due to some fault an extremely large current can flow in the domestic wiring. This can be very dangerous since the large current produces a lot of heat and it can start a fire. Let's understand what can cause the high current and the safety measures to prevent it. An extremely large current can flow in two situations: when there is short circuiting or when there is overloading. Let's first discuss short circuiting. If the plastic insulation of the live wire and neutral wire gets torn, then the two wires will touch each other. This touching the live and neutral wire directly is known as short circuit. The wires are made of copper and are good conductors of electricity. So when the two wires touch each other, the resistance of the circuit will be very low. As a result, the current flowing through the wires becomes very high. This will cause overheating in the wires and it can lead to a fire. Overloading is another case when a large amount of current may flow to the domestic wiring. When does overloading happen? Let's say in a house, 2 or 3 air conditioners, a water heater, an electric iron, and a washing machine are all being used at the same time. When too many electrical appliances of high power rating are switched on, then a very high current is drawn in the wires. This is called overloading. Overloading can also happen if many electrical appliances are connected to one single socket. In overloading, when the high amount of current flows through the household wires, it causes overheating in the wires and it can lead to a fire. Do you know what safety devices are used to prevent fire during short circuiting or overloading? That's right, safety devices such as the electric fuse and MCB, miniature circuit breaker, are used. First, let's discuss the electric fuse. The electric fuse is made of a thin wire of short length. The wire is usually a thin copper wire or an alloy of thin length, and it has a low melting point. When a short circuit or overloading takes place, the current becomes very large. This eats up the fuse wire a lot. The melting point of the fuse wire is much lower than the copper wires. So the fuse wire melts and it breaks the circuit. The electrical supply is cut off. This prevents damage to the wiring in the house or the appliances in the house. So the electric fuse works on the heating effect of current. The fuse or MCB are typically fitted just above the main switch and in the distribution box in the house. Let's discuss the properties of the fuse wire. Is the fuse wire thin or thick? That's right, the fuse wire is thin. Why? Because a thin wire will have a higher resistance. Due to the high resistance, the fuse wire will get heated up easily and melt. Fuse wires are made of different thickness depending on the maximum amount of current it allows. For example, fuse wire rating 5 ampere allows a maximum of 5 ampere current, and it will melt if the current goes higher than this. A 5 ampere or a 6 ampere fuse is typically used for the lighting circuit in the house, where the maximum current should be around 5 ampere. Now what should be the fuse rating for the power circuit in the house? That's right, 15 ampere or a bit higher, say 16 ampere. So the fuse wire for the 15 ampere fuse will be thicker than the fuse wire for the 5 ampere fuse. As we discussed, fuse is a safety device which protects the wiring in the house from issues such as short circuiting and overloading. Now what should you do if a fuse in the house blows? You should immediately call the electrician so that he can investigate why there was a large amount of current that caused the fuse to blow. Only after the issue has been found and fixed, the blown fuse should be replaced with a new fuse. These days, the electric fuse that have a fuse wire are being replaced with a new type of device known as MCB. MCB stands for miniature circuit, and it looks something like this. When the current becomes large, the MCB puts off the switch like this and cuts the electric supply. Once the fault has been corrected, the MCB can be reset like this. The advantage of MCB is that it does not have to be replaced. It can be reset by simply flipping the switch. Do you know how an MCB works? The MCB contains an electromagnet. When the current becomes high, the electromagnet becomes strong enough to pull and turn off the switch. This breaks the circuit and protects the wiring and appliances in the house. So the MCB works on the magnetic effect of current, and the electric fuse works on the heating effect of current. We have discussed about the fuse and MCB, which are used in the main fuse or in the distribution box of the house. Fuses are also used to protect individual appliances that may get damaged due to an excessive current flowing through them. Appliances such as refrigerator, television have their own fuses that protects them against damage from high current. For example, a television that uses 1 ampere of current typically has a fuse of rating 2 ampere. This fuse will protect the television from a current higher than 2 ampere. These fuses can also be found in power strips that have surge protection. This type of fuse is known as a cartridge fuse. As you can see, there is a thin fuse wire in this glass tube. If there is a large current, then the fuse wire melts and breaks the circuit. This protects the appliance that is connected to the power strip from getting damaged. Once the fault is fixed, the cartridge fuse needs to be replaced. The cartridge fuse is cheap. It costs about 10 rupees, and it can save your appliance that may cost thousands of rupees. The cartridge fuse acts as a safety device and works on the principle of heating effect of current. Let's place short circuiting and overloading on our concept board. Let's also put the safety devices, the electric fuse and MCB, which are used as protection from these issues, on our concept board. I hope the concept of domestic electric circuits is crystal clear to you now. Now you can be an expert, and when the electrician comes to your house, you can discuss these things with him.
Yes.